Alright, continuing on the Cornell Dubilier BF-50. I got all the capacitors and resistors replaced on this thing. Got this all cleaned up, put it back together, brought it up, tested everything, and there's some problems with it. And initially, I knew these problems existed, but I couldn't decipher what this meant in the parts list. R3, 4, 5, and 6. Bring that over here. 3, 4, 5, and 6. The 500, the 5,000, the 50,000, the 500,000 ohm resistors that were matched. Okay, and I made a note here that the 3 wire wounds, you know, are there, but there was this other one, the last one, R6, which I dubbed the resistor conglomeration, and you'll see why here in a minute. Because it said that they were matched, I didn't know what all these, I had some extra resistors in here, and I didn't know what they were because they weren't on the schematic at all. And I thought, okay, well maybe these resistors are matched to those wire wound R3, 4, 5, and 6, because they do split off of those areas. There's only 21 resistors listed on this schematic. R1 through R23 actually, so there is no R22. So actually there's 22 then. I was totally confused over the resistor conglomeration, what I have dubbed the resistor conglomeration, and I'll show you that right now. Perhaps I need to shorten this thing, and let's see if I can zoom in on it. I need to shorten it a little bit. Well, I think you can see it okay. We have a potentiometer in here. This is the center knob that is the capacitance adjustment, or capacitance, I don't know what they term it, but it's labeled microfarads on the plate, front plate. It is the capacity control. There you go. Simple enough. The capacity control is this center potentiometer, which I have another issue with on the schematic. We have 3 connectors on this potentiometer. One here, the center, wiper, this is the wiper, and then there's one here. So the way the schematic shows, R2, this is R2 in the list. R2 is a 50,000 ohm potentiometer. That's the part number, the Cornell Dubilier part number. Looking at the schematic, R2 has the stationary end, and then we have the wiper in the center coming here down to this R3, 4, 5, and 6 resistors. Alright, and then coming over here down to the transformer. And the stationary part connects to the rheostat, which is R1 here. So R1 connect the stationary, one of the stationary connectors on that R1 connects to the stationary connector of R2, and then we have a resistor going off of that to ground, which is a 2K resistor. And the center, the wiper of R1, goes to the row of capacitors, C1, 2, and 3. And we'll cover that more in a minute. So basically, what we should see is the center wiper on R2 be connected to R3, 4, 5, and 6 resistors, which it is not. So there's our R2 and the center wiper here. Following that wire right around comes to R1 on the stationary connector, which also has the 2K resistor coming off of it to ground, and that's it right there, going to ground. Grounded here. By the way, these are the lead jacks where the banana clip jacks go in here. Positive, negative, and the grounding strap. Okay. So this center wiper should be connected to resistors R3, 4, and 5, and we can clearly see it's not. It is connected to where this stationary, either this one or this one, should be connected to those resistors. Now, I'm sorry, the center should be connected to the resistors. However, this one, this stationary connector is 0. When you turn the dial all the way down to 0, it's this end of the potentiometer. Following this wire right here, over here, down, sorry, wrong wire, this is it, here, it connects right there to R5. That's R5 wire wound, this big spool of wire here. Okay. Now at one time I had this whole piece off and flipped over, and you'll see it in some of the previous videos where there was 3 wire wound spools. Now, so it goes like this. Here is R5, R4, and R3 just underneath this plate. And so we see this wire coming off the stationary should be on the center here, according to the schematic. This is the resistor conglomeration, which makes up R6. And it had me confused for the longest time. We have 250K resistors in a series, which should have been equivalent to the 500K value called out for R6 in the parts list. R6, 500K, plus or minus 2%. So that was a precision resistor. However, we see how precision it is. There's 2 in a series, and then we have parallel to it 2 additional resistors in parallel. So we have 2 parallel resistors in parallel with 2 serial resistors, and this is the best somebody could come up with for a 500K equivalent resistor. And it's only a half-watt resistor, however, they're plus or minus 2%. We can see these are silver, these are plus or minus 10%. So, when I measure this with my ohm meter, I get, I think it's like 576 kilo ohms. $573 right now. All right. So it's off, but it would be within the sloppy tolerance of 20%, plus or minus 20%. However, these were supposed to be plus or minus 2% resistors. So it's off. It's off a bit. And just as soon as I've ordered it, and as soon as I get it, I'm going to take this conglomeration out, have one single 500K resistor in there. And then we need to move this over here onto the stationary wiper. Now, do I want it on the 0 end or on the 50K end of that resistor? Here is the schematic. And here is that stationary connector. Should be connected to the station. So there's no indication there really which end is grounded or which end goes to this 2K Nothing, resistor. As far as I can tell, has ever been soldered to that high end of the potentiometer on the stationary lead. It's just been bent down out of the way. It's never had anything soldered to it. So I'm thinking if somebody came in here, did some repair work, monkeyed with this thing, got it backwards, when they put it back together, it didn't work. They decided it was junk, and they stuck it in a basement or something for 100 years, 75 years or so. So I need to repair that. Now let me show you some extra resistors that are not on the schematic, that are in this machine. One here, one here, which I had to put in serial. I just was replacing. I was just going through finding, I tried to find it on the schematic. If it wasn't on the schematic, I wouldn't put it back there, but I was confused over this matched deal, and I thought, well, maybe they gotta be matched to the thing, one end on, usually when you have matched something, you have two of them, but no, I think they're matched. What this means, I think, is it's matched to this 500, 5000, this stepped. These are stepped in a sequence for selection. Here, when you depress these buttons, for the values of the capacitors, ranges, a range of capacitors from like 0.001 to 0.01 and so on, something like that. Well, actually, I'll show you the values in the owner's manual, whatever you want to call it, user's manual. These are the values, the increments, 0.0001 to 0.0012, and so on. Alright, now this shows 1, 2, 3, 4, 5, 6 steps, or actually C6. If you depress C6, this is where it gets confusing. C6 is actually button 10. See that? But on the faceplate, it is labeled C6. Okay? And there are also, and it says press to discharge. So this is a discharger. When you're done testing and so forth, you will always press this button, discharge your capacitor, and remove it. And you'll see increment values 0 to 100, 100 to 200, 200 to 300, 300 to 400, 400 to 600. I'm not quite sure what that correlates to right now, but it correlates to this list. Alright? So basically, on the very, very small or smaller capacitors, because C6, or in other words button 10, will be depressed, there will be no resistors in the chain, or in the, involved in the valuations, and so you'll have 1, 2, 3, 4, 5, 6. So yeah, anyway, somehow it works out. This one as well is not on the schematic. However, this one, when I look at it, looks like it's been in here from day one. These, however, with this shiny brown wire insulation, looks like it was a newer addition, because it's only on this resistor, which doesn't belong, this resistor, which doesn't belong, and this conglomeration, which I'm sure was a repair job of some kind or another. Or the original was just these two in series because they equal 500K. But this, however, looks like it's been here forever. And I don't know, I think I know what this is. I'm just sitting here thinking about it. When I look at the schematic, this is our button bar area. Okay, we have the resistors, and we're going to point this out. You'll notice that 10, R6 comes down to button 10, but does not jumper over. R5 jumpers from 9B to 8B. R4 jumpers from 7B to 6B. R3 just goes to 5B, no jumper. Okay, button bar. Well, you can see it. Well, let's just say this is number 1. There are white off buttons down there. Number 1, button number 4 off. Okay, this is 10 down on this end. Button 10. Consequently, let me just tell you right now, C1, C2, and C3 are located right here. They come off of the R1 potentiometer. They all sorry, R1, exactly, R1 down here. They all converge right here on the center wiper, just as they do in the schematic. This is R1, center wiper, C1, C2, C3. This is the 2.4 microfarad. I believe it was, well, I'll just read the thing. It's 60 volts AC. You'll notice this, and be careful with this when you go to replace it. It is an AC, not a DC like all the rest, capacitor. And on top of that, it's plus or minus 2%. Good luck. I found that, and it cost me a lot of bucks. Alright, this right here, I just didn't have the right value of 0.12 in a plus or minus 2%. So I just created, this is plus or minus 10% probably, and it's just temporary until I can get one ordered. I think I ordered it along with these replacement resistor here. This is the mica capacitor, which is C3. Okay, so C3 goes to 10C, which is jumper to 9C. C3. I mean C3. This is 10C on the button switch. This is 10B. 10B is where R6 should be connected, right there. R6, 10B. Well, we follow it. There's R6, the conglomeration. All right. Recall, 9B and 8B are jumpered together. 9B and 8B should be jumpered, however, somebody stuck a resistor in here, which I thought, again, was matched to something, so I replaced that resistor with a good one. However, what I'm going to do now is I'm going to remove, I'm going to cut it here, and I'm just going to take this wire, bend it down, tack it here, and that'll be jumpered like the schematic says. Likewise, 7B and 6B. This is 7B and this is 6B. They are not jumpered. You see that? Open. However, this resistor and this resistor meet here, which is effectively connecting these two. However, there's two resistors in the middle of it. So when you depress button 6 or button 7, are you really getting what was intended? Values of just a straight jumper? No, you're getting something else somebody put in here. Again, brown insulation, brown installation. I replaced this one because it was bad, and I shouldn't even have put it in it because that's no good. Alright, now on the schematic, 6 and 7 go to R4. Well, this wire where these two meet, there's another wire here. Oops, right here. I have it labeled 1. That was just because this was 1 here and this was 1. I took these all off when I cleaned it, all the corrosion off. But anyway, following this wire, it comes all the way around to these resistors, R4. Okay, which is the center one. That's the wire right there. Okay, that wire. Now, which leads me, it just brings up the question, why? Likewise, this, not on the schematic, it comes from 5B, and I'm thinking that this was a wire. That's why it looks like it's been there forever. This was a wire from there to there. Somebody cut it, inserted this resistor. Why? I don't know. It's only a 50 ohms. But looking at the size of it, it's probably a 1 watt, 2 watt, something. I don't know why they stuck that in there. Alright, so we're all rewired up here. Going over this again. This is 10B. This is our conglomerate network of resistors. I came off of the center. Also off of that center is this wire. This wire comes under here, goes into here to the wire round resistor array. Alright, so 10B. Okay, also coming from R5, this wire, coming to 9B, jumping to 8B. This wire coming from R4 to 8B, I'm sorry, 7B, jumping to 6B, and then this wire coming from R3 going to 5B. Okay, now that leaves this thing useless. So I'm wondering if this was original or added by whoever did all this stuff. Now, I plan to replace this with one single 500 ohm, 500K resistor.